Hey everyone, welcome to Nick's Fix. Today we're going to be covering two different projects that I've created to help you with your 3D printing experience. I'm using a resin printer, specifically the M3 Max from Anycubic, including their wash station. The two projects that we're going to cover today are a filtration system for IPA that cleans out the residual resin that is left after you wash your prints in the washing bath. And the second is a heating band with a thermostatic relay to help control your resin's temperature within 1 degree. All the parts are in the description. This is the IPA filtration system that I've created. The parts consist of a basin to put your prints in to wash them after you've printed, some vinyl tubing to connect to a pump, some more vinyl tubing to go through this little reactor here, and then two particulate filters that go from 5 micron down to 0.5 micron here, and then back into your receptacle. Key components here are the pump. You can't use just any regular pump. This is specifically a diaphragm pump, and the diaphragm itself from this manufacturer, Seaflow, uses a diaphragm made out of santoprene. Santoprene is highly resistive to IPA, any types of alcohol, and other caustic chemicals. The vinyl tubing and also the filter housings and the filters inside are also resistant to chemical erosion from IPA. But do your due diligence, please. Here in this coil, I have the vinyl tubing wrapped around 4 separate times, so it goes into a loop 4 times. And around that loop, I've wrapped 2 8-foot LED strips that push out 405 nanometers of wavelength. That is the exact wavelength that you need to cure IPA. So the concept here is that the saturated IPA, whenever you're washing your prints, is pumped through a curing ring, and the resin would consolidate and coagulate and then be caught by the filters. This system I've been using Anycubic's standard resin, and I've put 2.5 kilograms of resin of prints through this filter, and this is what it still looks like. You can see that whenever I turn on the IPA wash system, the LEDs, which are facing towards the tube, turn on. What this is doing is exposing any residual resin that is left inside of the IPA before it hits the filters. I only leave the wash filtration system on whenever I'm washing prints because the amount of flow that the pump can push through this system, it means that this entire 2 gallons of IPA will cycle through this entire system 2 times per minute. The gallon is rated at 5 gallons per minute, so 2 gallons worth of IPA roughly gives me 2 complete cycles through. So if I wash my prints for 3 to 4 minutes in the IPA, that means that this has gone through 6 to 8 times through this filtration system, constantly filtering. That also reduces the risk of the pump overheating or anything like that occurring. Safety-wise, though, the pump does have thermal protection and will also shut off if it ever reaches 60 psi. At that point, I would imagine that the filters are completely filled and saturated, and it'd be time for a filter change. But right now, after 2.5 kilograms worth of resin prints have gone through this wash, there's no sign of any flow degradation since the very first time that I put it in. I want to call out that the way that this system is meant to work is to start with very clean, fresh IPA and continually cycle it. So for a larger system with many, many resin printers and a few wash stations, this would be really beneficial. Or if you're like me and just don't like cleaning up, this is more of a set it and forget it type way of doing it, and you would only ever need to change out these filters and top up a little bit more isopropyl alcohol due to evaporation. These are a few prints that I've been working on. I'm printing prototype housing for another project that I'm working on, and you can see that these prints are very clean, very easy to pull off the build plate, and they wash surprisingly well. Very high detail, and no issues or stickiness left from the resin wash. You can see the results here. In the first image, I have the very clean, pure 99% isopropyl alcohol. In the second comparison image, I've taken the IPA that has been in the vat or in the tub and not cured at all. And you can see that there's very, very little color discoloration. In the third one, I left that sample in my curing station for 25 minutes to see if any residual resin was left inside of the glass. And you can see by comparison, there's no resin left in the glass, even after 2.5 kilograms of resin prints have gone through 2 gallons worth of IPA. My second project here uses a silicon thermal heating band wrapped all the way around the vat with a Velcro strap to keep it tight against the vat, and then a thermostatic relay to control the temperature. There's a thermal probe that rests inside the vat outside of the print plate area and controls temperatures within 1 degree. I have it set at 31 degrees Celsius, which is being sensed at the very edge of the vat, which gives temperatures on the inside around 28 degrees Celsius. This system will turn on within 1 degree difference. So once it goes down into 30 degrees, it will turn on. And the band itself is 150 watts. So heating time of a vat from 20 degrees Celsius to 31 degrees Celsius takes about 2 minutes. So incredibly quick. I found that this is giving me successful prints throughout my printing time with this band attached. And I have a lot of temperature swings in my garage, and that's why this helps so much. That's it. Thanks for watching. Be sure to check out the parts description in the bottom for all of your links. Be mindful, those are affiliate links, so I might make a little bit of money on the side for you clicking through and buying those things. I'd also want to give a huge thank you to Ty over at Table Flip Foundry. His Discord and community have been pivotal in the research that has gone through this. So go check them out and go check out their Discord. Thanks so much.